The real reason NASA is obsessed with asteroids. The crucial significance of asteroids for science, planetary defense, resource use, and future space exploration is what motivates NASA's fascination with them. NASA regularly watches and works to mitigate the possible impact dangers that asteroids represent to Earth, contain important commodities like metals and water, and provide unique insights into the early solar system. NASA defends the Earth, develops economic opportunities in space resource mining, and advances technology for human spaceflight through missions to study, sample, and even reroute asteroids. Number 7. Windows into solar system history. About of the oldest and most unaltered materials available for research are asteroids, which are primordial relics from the solar system's birth about 4.6 billion years ago. A comparatively pure record of the early solar nebula, the cloud of gas and dust from which the sun and planets formed, is preserved by asteroids in contrast to planets, which have undergone significant geological activity, atmospheres, and weathering. NASA missions like Lucy, which passed by the main belt asteroid Donald Johanson in 2025, have uncovered intricate geological features, including cratered surfaces and contact binaries, which point to a history of catastrophic collisions. Number 6. Sources of valuable resources. Precious metals including platinum, gold, iron, and nickel, as well as water trapped in hydrated minerals, can be found in abundance on asteroids. Because it can be electrolyzed into hydrogen for rocket fuel and oxygen for breathing, water is particularly important for future space travel, allowing for life support systems and in-orbit refueling stations. NASA's results from OSIRIS-REx's Bennu samples demonstrate the viability of collecting water-bearing minerals in space by confirming their existence. By using asteroid resources, long-term human presence in space could become sustainable by significantly lowering the high costs and logistical difficulties associated with launching supplies from Earth. Number 5. Planetary defense. As demonstrated by previous extinction events, asteroids pose a real threat to Earth because of their capacity to have devastating effects. The mission of NASA's Planetary Defense Coordination Office is to identify, monitor, and describe near-Earth objects (NEOs) that may be dangerous for collisions. Space-based observatories like NEOWISE and ground-based telescopes like PAN-STARRS are used for ongoing monitoring. The significance of being vigilant is underscored by recent occurrences, like as the near but safe passage of asteroid 2025 CV. A proof of concept for deflection tactics was provided by the DART mission's successful kinetic collision on the asteroid Moonlet Dimorphos, which showed a workable way to change an asteroid's trajectory. These initiatives will also be aided by the European Space Agency's Hera mission, which will investigate the Didymos binary system and provide comprehensive information on the composition and impact response of asteroids. In order to safely disperse bits of smaller asteroids, NASA is also investigating rapid response methods like kinetic penetrators, which destroy asteroids just before impact. To protect Earth from asteroid dangers in the future, these planetary defense projects are crucial. Number 4. Origins of life clues. It's possible that asteroids were essential in bringing the water and organic chemicals needed for life to originate on Earth. The return of Bennu samples from the OSIRIS-REx mission showed an equal mixing of amino acid enantiomers, which are essential components for proteins and genetic material. This suggests that asteroid collisions may have fertilized the organic inventory of early Earth. Water rock interactions on Bennu's parent body created conditions that for sophisticated chemical evolution, as evidenced by the existence of hydrated minerals on the island. Furthermore, knowledge of material interchange in the Earth-Moon system and the variety of organic delivery systems is increased by the discovery of quasi-satellite asteroids like 469219 Kamo'oalewa, which may be lunar debris rich in silicate minerals. By finding important chemical signatures and environmental conditions, the study of these materials improves the hunt for life beyond Earth and contributes to theories about how life's building blocks were disseminated throughout the solar system. Number 3. Scientific exploration and discovery. Through the direct examination of alien elements that cannot be thoroughly described by distance sensing or meteorite research alone, asteroid missions provide unmatched scientific prospects. Prior theories on asteroid geology and space weathering have been called into question by OSIRIS-REx's thorough examination of Bennu's surface composition, particle size distribution, and organic content. The structural diversity and collisional history of Trojan asteroids, relics of primordial material from the outer solar system, were also revealed during Lucy's flyby of Donald Johanson in 2025. Additionally, by improving spacecraft navigation, autonomous sampling, and sample return capabilities in difficult low-gravity conditions, these missions act as technological testbeds. The collected scientific data informs planetary defense plans, directs future exploration missions to asteroids, comets, and planetary moons, and improves models of solar system creation, asteroid evolution, and planetary processes. Number 2. Accessible targets for space missions. Near-Earth asteroids with Earth-like orbits, such as Bennu and 469219 Kamo-o-Alewa, are relatively close and small, making them ideal targets for robotic spacecraft due to reduced travel time, fuel requirements, and mission complexity. Their accessibility enables NASA to conduct detailed reconnaissance, sample collection, and return missions that would be prohibitively expensive for more distant bodies. The 2025 Tianwen-2 mission plans to collect samples from Kamo-o-Alewa, using both touch-and-go and anchor and attach techniques, demonstrating the growing international interest in these accessible space rocks. These asteroids serve as proving grounds for developing and validating new exploration technologies and mission architectures, building experience and confidence that will support human missions to Mars and beyond. Their study also enhances understanding of near-Earth asteroid populations, orbital dynamics, and potential resources. Number 1. Potential economic value. Asteroids contain vast quantities of valuable metals and minerals, with some estimates valuing individual bodies at billions or even trillions of dollars. This immense economic potential could catalyze the development of a space mining industry that supplies both Earth and space infrastructure. NASA's Asteroid Redirect Mission, ARM, although currently on hold, demonstrated concepts for capturing asteroid boulders and bringing them into lunar orbit for astronaut study and resource utilization. NASA's focus on asteroids is more than just curiosity. It's a vital effort to unlock our solar system's history, protect Earth from potential impacts, and pave the way for future space exploration and resource utilization. As technology advances, studying these ancient space rocks will continue to be key to safeguarding our planet and expanding humanity's reach into the cosmos. If you liked our video, please hit the like button and subscribe to our YouTube channel